At this point, there's a couple things I'd like to bring up in order to make your Fuzz shader experience a little smoother and more efficient. To begin with, let's talk about updating geometry. You're most likely going to be updating geometry very often in order to accurately create the surface effects that you're after. It's important that you update your geometry nodes after any adjustment in order to visibly see how your settings are progressively altering your surface geometry. There are three ways you can go about doing this. The first way is to update by using the geometry execution button that appears in the top right of your real-time view after you've made a geometry adjustment. You can see this highlighted in the top right image of this slide right here, just to the left of the project panel. The second is to locate the execute geometry node button located within the property subtab in the material graph. This is also illustrated on this slide in the bottom right image. You can see that here just underneath the appearance accordion. And the final and fastest way to execute geometry is to simply use the Alt-G command. This instantly triggers the execute geometry update, whether you're in the material graph or in the real-time view. Another important factor to consider is how your normals are oriented. In order to have success when mapping your fuzz effects, you need to ensure your normals are oriented in the appropriate direction so that fuzz growth is visible on your object's surface. If your normals are incorrectly mapped to the direction you'd like the strands to extrude, then you may experience your geometry updates to failing to produce visible results. Typically, this is not an issue. However, it is something that I've come across before, and it's definitely worth being aware of. Previously, adjustments of normals needed to be made within your modeling software of choice. However, in 9.1, normals can be flipped in program. Here you can see an example of a model that has normals mapped incorrectly, which is causing the fuzz application to be inverted on the body to the right. If this was an enclosed object, you would not be able to see the fuzz and may assume that your fuzz application did not work. Lastly, I'd like to bring attention to something I've experienced while working with fuzz. In some instances, adjusting the density slider has not yielded my desired density. You may have experienced this as well, depending on the scale or type of fuzz application you're working with. Through some experimentation, I have noticed that both the randomness and segment sliders may inadvertently affect the overall perception of surface fuzz density on a given material. When randomness is higher, it causes some fibers to shift direction in a manner that reverses their direction and causes them to not be visible from the front of the material. This may cause fuzz to look less dense overall. If you look at the images on this page, you'll notice two examples. They both share the same settings other than randomness. On the first image, the top image, randomness is set to 0.2, while the second is set to 2. You can clearly see that the low randomness setting, no fibers are visible from the back, while the higher number generates a large amount of visible subsurface fibers.